All right, well, I guess we'll kind of go ahead and get started here. So welcome to the talk on scalability and high availability. My name is Dan Bishop, and I'm one of the partners over at RavenHQ. And you can find my contact info here, or hit me up if you have any questions about the nuts and bolts of RavenHQ or any topics of that nature. Before we get started, curious to know do we have any other Canadians in the room here? I'm from Toronto, Ontario. Got one over there. I'll have to come say hi to you afterwards, but it's okay. I always like to look for the other Canadians in the room, and I'll apologize now if I apologize to you guys, because just kidding. We've got that stereotype of always saying we're sorry. One of the, hang on a second. This is not the right clicker. This is the right clicker. So I've been working on the .NET platform for approximately 10 years, back from the 1.0 days all the way to wherever we're at now, whatever version, 4.5, 5.0, whatever you want to call it. I'm a husband and a father of 3 boys, age 1, 4, and 6. Like I mentioned, I'm from Toronto, near Toronto, Ontario. So it's still winter up there for us, which is no fun whatsoever. When I'm not working on RavenHQ, I enjoy building REST APIs and kind of backend services for mobile applications. And lately, I've been getting my hands kind of dirty with the Xamarin platform, doing iOS and Android cross-platform stuff. So some of the discussions earlier around running Raven embedded inside Xamarin is something I've been thinking about. And I don't know, we'll see if I get time to make any headway on a project like that. So first of all, let's start with some definitions. And I'll use that term a little bit loosely here. I mean, there's lots of different ways you could define scalability and high availability. But we'll kind of go with what I've put together here, which is for scalability, that refers to the performance of your system should increase linearly with the amount of resources that you add. So resources that you're adding could be more CPU, that could be more memory, it could be extra servers, it could be a faster disk, it could be any of those things. The idea is if you add one extra server, that should get you some increase of X in your performance, whatever that metric might be. So it's kind of vague, but that's generally the definition. Then with high availability, a working definition here would be that that's kind of a system that's going to be up and continuously running for a long period of time. Again, kind of a vague definition. And that's going to mean different things for different people, what it means to be continuously operational. Like in some domains, that might mean, you go down once a day every month, and that's good enough to be continuously operational. And in other systems, of course, that's not good enough. So at its core, high availability is all about redundancy, and that could be hardware redundancy, data redundancy. It's about having things in more than one spot and having a backup plan should something go wrong. With scalability, there's basically two ways you can think about scaling. That's to scale up, which would be vertical scaling, or to scale out, which would be horizontal scaling. So when should you think about scaling? Really, the primary thing here would be the business requirements. If your business is coming to you saying, hey, developer guy, why is it taking 10 seconds to load this page? And you might do some investigation, find out that your server CPU is just hammered, and you've reached the limits of your hardware, and you've got to do something about that. Alternatively, maybe you have a whole bunch of concurrent users, and they're all trying to access your system at the same time. Maybe you're building a shopping site, and there's an infomercial running, and right during that 1 hour of the infomercial, you're expecting to get this huge spike of traffic. So you need to think about how your application might scale in those situations. Maybe you don't have a lot of data, but maybe you don't have a lot of concurrent users, but you've got really, really expensive queries, kind of reporting type queries that those users might be running that might require you to scale. And of course, the kind of obvious one, I guess, would be just having simply a ton of data that's too much for a single server. So again, back to this discussion of should I scale up or should I scale out? You might want to think about scaling up to remove specific hardware bottlenecks. So an example would be on RavenHQ, with a few of our different servers, we were noticing that our request times were, back to the performance counters that Jonathan mentioned, we were observing that the overall request time from tenants on that server was trending upwards over time. And we kind of did some analysis, and we were like, this is strange. We've got lots of spare CPU headroom, lots of spare memory headroom. What might be going on here? And of course, then you went and looked at the disk performance, and that's where you found this problem. So we were able to kind of, with the Amazon platform, we can vertically scale that disk through provisioned IOPS to kind of just give us, we can pay more for that resource, which would be vertically scaling, and that brought the disk performance more in line with our CPU and our memory that was available in the box. So we didn't have that bottleneck anymore. It was kind of a level playing field. Another reason to scale up is to minimize your support and licensing costs. So by support, I mean the human element. You know, if you're running one server, kind of by definition, that's easier if you're kind of doing DevOps or you're in that role of maintaining that server. It's easier for you to manage if there's just one of that server as opposed to 10, you know. So and of course with licensing, if you've been using some software that's got a per core license, you can keep your costs down by scaling up. For scaling out, of course, you're going to achieve a much higher performance ceiling. So, you know, there's obviously limits to what a single server can do. So if you are going to hit those limits, you are forced to then think about scaling out. Of course, scaling out also enables you to think about being highly available, because now you've got that idea of redundancy. You've got more than one of your server, your hard drive, whatever it might be. So you've got a lot more options that open up to you there. And if you are going to think about scaling up, I would strongly encourage you to think about investing in automating the configuration or the setup of that server, whether that's through Amazon scripting tools, Azure PowerShell scripting tools, whatever it might be. You know, maybe the first one is okay to do manually, or sorry, the second one, but you really want to think about what your story is going to be there if you plan on scaling to more than just one or two additional nodes. So one thing to highlight here is that scaling up or scaling out, it's not always an obvious choice. When I was kind of preparing this, I was expecting to go look at the different cloud vendors and sort of see, oh, okay, yeah, we can kind of chart that familiar nonlinear curve where it's just kind of growing, and as you want more CPU, it's just going to cost you more money. Of course, what I found was not exactly that case. This is the pricing for the Amazon EC2. I think on the left it's the compute optimized instances, and on the right it's the memory optimized instances. But it's a perfectly linear pricing scale. So if you need 32 cores of CPU and you're currently running 10, your best bet is to just pay Amazon more money. If that's the only thing you need is more CPU, you don't care about high availability or anything, just give them more money, and that's going to give you the scalability. That's likely to give you the scalability requirements that you need. There are other things you might consider. You might run into other types of bottlenecks. Maybe you're going to hit the limit of 4,000 provisioned IOPS on your disk or something. So I shouldn't say that. That's not always true, but it's something you really want to think about and make sure you make an educated decision there. So what does it mean to be scalable with RavenDB? There's really two options. One is sharding, and the other is replication. So we've kind of various people have touched on the concepts of sharding, but basically that's you're splitting your data out across multiple different servers, or at least different databases. And each server is the owner of documents in its shard. Replication, of course, is different because that involves you physically shipping or copying a document from one server to another, and you end up with documents existing in multiple places. So when might you want, so a little caveat here is, I'm going to talk a little bit about sharding. Because it has kind of been covered by some other talks, I'll probably go quickly through this section and focus a little bit more on replication. But anyways, let me know if you've got questions as we go along or at the end. So you'd consider sharding if you had a lot of data, if you had really high volume of queries that you needed to run, or if you had maybe a common example is really strong data locality. So Mauro had that example where maybe you're running a server in Italy that's got orders from Italian users, and it's likely that those orders are going to be accessed by people in Italy. So that I think is kind of a very common example that people use for sharding, is based on geography. Another example would be natural partitions in your data. So that might be something like you've got a multi-tenant system, you've got different customers, and you might want to think about putting them each into their own shard. One thing you do want to think about is that, let's use that multi-tenant example. just because it's multi-tenant, you want to think, again, carefully about, does it make sense to shard in that example, or are you just simply better to flat out create different tenants in Raven and have them running in their own silos? And that really comes back down to the business requirements. Is there some use case out there where you need to easily run queries across all those different partitions of your data, or are they just basically completely in their own silo? And if they're in their own silo from top to bottom, you're probably better off just going with a separate tenant or a separate Raven server to host those things without introducing sharding per se. So sharding in RavenDB is implemented in the RavenDB client. So that's awesome because it means there's a really low barrier to entry. You can get up and running with sharding with just a couple lines of code in an obviously naive implementation. You don't need to do any specific server-side customization to make this work, and you're given lots of extension points in the client API to kind of make it do what you want. So the way it kind of works is that the client will modify your document IDs to embed the shard ID in there, and there are, of course, pros and cons to that approach, and I'm not going to jump into exactly what all that entails because it's very situational. But having that information in the document ID allows the client to kind of optimize its queries and allows the client to say, I know that you're trying to load this document, and I'm just going to go straight to that shard server and grab it. When it comes to querying, the client takes care of a lot of that complexity for you. Let's say you had 3 shards and you're trying to find the top 10 most expensive products. What the client will do is it'll go issue that query against each of those 3 shards. Each shard server will run that query locally, return 10 results, send those overall, the client will get 30 results back, and it will do the overall sort to get the top 10 across all your servers and give that back to you. So a lot of that's just going to work out of the box, which is great. So of course, the biggest question with sharding is how are you going to decide how your documents are going to be split up between servers? So another kind of very common example is this one of, you've got 2 shards, and I'm going to put customers with last name A to M on one shard and N to Z on the other shard. And then I'll put their orders on their respective shards along with those customers. And this sounds simple and easy, and maybe it is easy to do, but the reality is it's not meaningful. Why a customer with the last name A really has no relationship or is not likely to be the same as a customer with the last name of B. It's arbitrary. You may as well choose a blind sharding implementation rather than trying to make it look like you're doing something fancy. And of course, your data might not be balanced if you went with that approach. So another example, this example here is the kind of blind sharding example. I have 3 shards, A, B, C, and I'm just going to use round robin and go first session gets opened against A, then B, then C, and my data is just going to get stored here, then here, then here. And that's great because it gives you better throughput on your writes, and your data kind of naturally gets balanced evenly across all your shards. But the downside is because you've given no context to that separation, your queries have to hit all the shards. So the final example I'll show is this geographical example where you've got USA, Europe, and Asia. And that's good because you'll minimize your latency for your users. But the reality, again, is that this is costly to implement and costly to support. Therefore, it's maybe not that common. I'm not sure if people here have experience kind of implementing this type of solution, but it obviously has its place, but it's not something you'd want to just rush into just because it sounds cool. So the moral of all of that is that choosing a sharding strategy can be very hard. You really need to consider how your data is going to be used. You really need to think about the business requirements for that data. What's your query load going to look like? What does the business think would make sense in each of these situations? And you really need to think about how you might handle changing that shard configuration. And as Mauro pointed out, changing that in production is going to be one of the most difficult things you'll ever probably encounter. So you don't want to make a light decision here. So I've got just a quick example. I'll go quickly through this. You've got your shards that you set up in a dictionary. This is the simplest example for setting up sharding. You just create a shard strategy. You create a sharded document, store and initialize it. And from that point on, you're kind of working with it as you don't even realize you're working with sharding. The first session will be opened against shard A, second session against shard B, and then your third session is back on shard A. In this example, I put customers 1 will go to shard A, customers 2 on shard B. But the problem here is that, oh shoot, orders 1 and orders 2 both ended up on shard A. So that's not a very useful setup because orders 2 actually belongs to customer 2. So it doesn't make sense to have them over on the customer 1 shard. So what can we do about that? Well, if we take a look at this shard strategy, we can give Raven just a little bit of information there to say, hey, hang on, don't be completely blind about how you're doing this sharding. Go ahead and use the round robin strategy on the customer document. But when it comes to the order, make sure these orders are staying with their respective customers in the shard. So now down at the bottom here, you end up with this session that gets open is going to end up talking to both shard A and shard B, depending on the context of the data that's being used. So that's just going to happen under the covers for you. And what did we have to do? 2 extra lines of code to set that up. So again, this is admittedly naive and probably doesn't make sense in a lot of real-world situations, but this is how simple it can be. You've got the right data on the right shard. So yeah, go ahead. Pardon me, can you repeat?
Have the customer ID.
Yeah.
Is it assuming that customer ID?
Yes, that's right. The order has a full reference, including the shard key.
So it looks at that, pulls out the shard key.
Yeah. Yeah, that's right. That's right. So that's, again, kind of a requirement, I guess you could say, of the shard, the way Raven's sharding implementation works, is to have those shard keys embedded in the document ID.
Now, if you had another document that had a reference to the order.
Yeah. You could. Yeah, you could keep going with that sharding on implementation, right? You could add, if you had something underneath an order, you could go ahead and shard down the hierarchy like that. And then there's all these extension points, right? If you want to kind of provide your own way of defining the shard key so that it's not showing up at the beginning, but it's at the end or something, there's all these extension points for that. And I won't jump into that, your best to kind of look at the documentation for how some of that might work. The things I will highlight, though, is that there are limitations, of course, with sharding in RavenDB. One of them is that doing includes and transformers. That's only going to work for documents that are on your same shard. And if you kind of understand how those features are implemented, it makes sense. Those are running server side, and the server only knows about the documents in its shards. So that's why that's limited there. There is no sharding support for attachments. You're limited to using string IDs. So if you have GUID, if you want to use a GUID ID on your model and use Raven's document conventions, things aren't really going to work too well for you there. And there's no way to auto rebalance your shards. So you started with 3 shards, now you're going to add 3 more. Let's say you're using round robin sharding. So you've got, yeah. You can auto. Well, I know you can customize the shard resolution strategy.
Yeah, but what you're talking about, 8 new documents.
Based on it. Okay, so Oren's saying that you can weight new documents that are coming in to a new shard. And I know you're referring to, and that's the shard resolution strategy, and you can do some time calculations there to kind of say, if this document is being persisted and it's within the last 3 months or something, then put it on one of these new shards. So you can get into that. I guess, the point I was kind of making is that that's not just going to be out of the box. You don't just say, wake up one morning, put your 3 new shards into the mix, and have some auto magic process that takes care of that for you. So there's no one-size-fits-all approach. Sharding is all, you need to think about the business requirements. You need to think about all sorts of things into the future and plan accordingly in order to have a successful deployment there. So moving on from sharding, let's talk about replication. So one of the key things about replication in RavenDB is, actually before we do that, can I just have a quick show of hands? Who has implemented replication in Raven previously? or by implemented I mean used it on a, set up 2 servers to send documents from one place to another. Okay, so maybe about half of the people here have used that. So one of the things that's really important to remember about replication is that in RavenDB, it is one way and it's managed by the source. So commonly you'll hear, so what that means is I've got server A and I'm saying server A is going to send documents over to server B. In this, the way I've drawn it, I've intentionally not labeled it as master and slave. I've said I'm choosing to avoid that terminology because that's not really what's going on. The slave doesn't know he's a slave. The master maybe he's not a master, maybe he's an intermediate slave or something like that. Again, I'll use the air quotes around those terms. But obviously for speaking purposes, we will refer to that configuration as master slave. I just want to point out that that's sort of different from how Raven's implemented things internally. Then you've got, okay, well, what if I've got server A and server B? Not only is server A pushing docs to B, B is pushing docs back to A. This would be kind of commonly referred to as the master-master configuration. But again, there's nothing stopping B from also pushing docs somewhere else. So you've got that same configuration, and let's go add server C. Maybe server C is there for reporting purposes. Maybe he's there for sort of a read-only failover, a read-only mirror in case everything goes down and a bomb goes off in the data center. You've got server C sitting there somewhere, and he's not really powerful, but he's there for you. Well, maybe that's not the case. Maybe server C is actually replicating data back to A, or maybe he's also additionally replicating data back to B. I mean, you can do any of these things, right? And this is where the terminology of master, slave, master, master really starts to break down, because each of these servers can independently decide to push docs wherever they want. And that's a really important thing to just kind of keep in your mind as we're talking about this. So replication's configured through the destinations document. So that, this might be familiar. Again, I'll do the apology to Judah for the, no, I'm just kidding. Yeah, I know, I figured I had to do it because everybody else did it. But yeah, this is the way it looks in the old studio, or the current studio, if you will. And we'll get into a demo, and we'll go through kind of a really quick setup of what this looks like. But this is kind of where the UI and the underlying document for how that's configured. Again, that document lives in the source and is managed by the source. So let's talk about how that process works. We've talked about the fact that it's kind of one way, and the source is kind of the manager of that process, or he's in charge. So replication is entirely, it depends on e-tags to track its progress and to know where it's at in that process of replication. One of the things, as soon as we start talking about e-tags, I guess I'll just kind of clarify that. What an e-tag is, it's a sequential GUID. It's a GUID that you can sort based on, I guess, time, for lack of a better purpose. So you can look at this e-tag and know that it came before or after this other e-tag. But another thing to point out with replication is that although you have the same document copied or mirrored, if you will, on 2 different servers, that document is going to have a different e-tag on each of those servers. And I believe that's because the e-tag algorithm to generate an e-tag takes into consideration the database ID that it's running on. And of course, you might just have a different number of documents. Maybe you had some pre-existing docs in the one database, and then you started replicating new stuff in there. So there's absolutely no guarantee that your e-tags are consistent across replicated nodes. So with that being said, the way it works is after a document is written, a background process spins up to start handling the case of replicating that document to any of the destinations that it needs to go to. And because that's happening in the background, that replication process, it doesn't directly affect the read-write performance on the source node, on the source server. So it's much like indexing. It's eventually consistent. It's not, if I was replicating from this server to 500 other destinations, it's not going to change how long it takes. It's not directly going to affect how long it takes for me to store a new document on the source. Obviously, there's indirect side effects there, like if you have all these 500 background threads pushing data all over the world, I mean, that's going to cost something, and your server is going to suffer as a result, but it's not a direct connection. So let's kind of just look at what it looks like if we imagine the source talking to the destination. So that process starts out, the source will ask the destination, hey, what's the last document e-tag that I sent you? The destination is going to respond with, in my example here, 15. Now it's important to note that this 15, this isn't the destination's version of his latest E tag. This is the destination saying the last thing you sent me was the document E tag that you refer to as 15. So it's 15 from the perspective of the source, not maybe the destination is already up to, he has some totally alternate set of E tags going on. That's not what we're talking about here. This is the source's E tag. So then the source says, okay, well, I've already gone up to E tag 22, so I better go ahead and send you these new docs because I can see that you don't have those 7 documents. So he's going to push those across the wire. Destination is going to respond and say, okay, I got the docs. Now the source is going to be stupid and silly and say, well, what's the last doc E tag I sent you? Going to repeat that process. Now destination is going to say 22. And the source is going to say, okay, we're all up to date. I'll check back with you later. So that's kind of the basic handshake process that goes on when the source is talking to the destination. But what I want to do now is just take a minute and quickly go through a demo of what that looks like. We'll just create we'll create 2 databases, replicate a doc from one to the other, and show kind of how Raven tracks some of this stuff internally. So what I have here is I have just spun up 2 different Raven servers. The details, oh, I'm sorry, my resolution is horrible over there. 1 second. We'll pretend it doesn't look so bad right now. That didn't appear to help. Okay. Well, we will just go with it as it is, back in the original setup there. And we'll do our best to deal with it. Okay. All right, so here on I've got here, I'll just minimize that. Alan, thank you. Sorry guys, technical difficulties. Okay, so on let's call this server, this is localhost 8090, let's just call that our master. So let's go ahead and create sorry, I'll actually just call that master to keep things clear. And we'll go ahead and enable the replication bundle and create that database. And we're gonna go over here on the destination and create another database. Again, with the replication bundle, because we all know bad things happen if we don't set that up right away. So now I'm going to jump into the master, go over here to settings, replication, and I'm going to say add replication, and I'm going to type out the URL of that destination. I'm going to just put in my computer name, and I'm going to put the database name here as, what did I call it, destination. And that's pretty much all I need to do. So some of the other options here, I'll touch on some of these other options a little bit later. Some of them around authentication, username, password, API key, those types of things. For now, though, I'm just going to keep it simple, give it the URL and the database. So save that. Okay, so after saving that, here in the master, I've got this Raven replication destinations doc, just the document representing that UI we were just looking at. So I'm going to go ahead and just create a new document, very simple, test 1. Let's not even put any content in there. Let's save that. Got that document in our database. Now it's coming over here to the destination. And bam, we can see that test 1 is there. So of course, that's the simplest case. We were all expecting that was going to work, and it did, which is excellent. So let's take a look now inside test 1. I'm back over here on the master, or yeah, I called it the master. Yeah, and in here you can see that Raven's written some information. It's got this Raven replication source, which is this funny-looking GUID. It's got a version, and then it's got the entity name. So this source here, this is coming from the database ID, and many of you may not be familiar with that concept, but internally Raven is tracking for each different tenant database. It's assigned a unique GUID identifier. Oren kind of alluded to this in the talk on Boron earlier, that he likes to have a unique identifier for each database. So we can actually go look at that over here on the status page. At the bottom, sorry. Oh, I think it's getting cut off on my screen. If you were to scroll down here on this page, you'd see a database ID field showing up on the stats, and that would have that same GUID that we were just looking at there. So that lets the replication process the replication process uses that information to know which update to that document was made on which server. So over here on the destination, if we go look at the metadata, we're going to see basically the same thing, that this is C0, and we've got our information there. Additionally, here on the destination, we're going to see that there is this document, Raven replication sources, and then this funny looking thing, which is basically the URL. What this is this is the URL of the source server that pushed documents here to the destination. So the destination is just going to keep track of every different source that's sending him documents. He's going to create his own internal tracking here so that he can keep track of what we talked about here, which is the last document E tag and the last attachment E tag. And again, here's the server ID, the server instance ID. So this, to drive this point home, this document E tag is the E tag from the source server. This is the last thing the source sent over. This has absolutely nothing to do with the E tag structure in the destination database. So if we go to this test document, again, still on the destination, look at his, oh, it's right here, look at his metadata, take a look at that E tag there. With my luck, these will happen to be the same. Yeah, so we can see there that they're different. Here on the source, we've got, it ends in a 4. Over on the destination, it's ending in a 1. So that's kind of proving that point, that those E tags are different. You need to be aware of that because it can affect you as you're running your app. So let's kind of get into what that might look like, or how that might affect you. So we kind of looked at how, first of all, I guess I'll ask at this point, is there any questions about that process, about how that handshake works between the source and the destination, and how Raven tracks some of that internally? Yeah?
I guess the post-op, if you enable replication on the database.
Yeah. Yeah. Yeah.
The E-tag still won't line up.
No.
So I mean, the protocol will start with E-tag I sent you.
Yeah. Okay. So the question was, why is it important to have the replication? I think to summarize your question was, why is it important to have replication, the bundle enabled, before you start replicating documents, right? Because his question was, well, what if I just use Smuggler to kind of make sure that each server had the same set of documents on it? So I can kind of guarantee that the docs are in both places. Then I turn on replication bundle in both places. Then I start pushing docs across, and it should just kind of work. The short answer is it will work. It will look like it works the first time you do that. But then as you make subsequent updates on the master, those documents in the master, or sorry, I'll say the source, they don't have any of the metadata around replication. They don't have kind of, well, I won't go there, but the information about, hey, my replication source was this GUID and my version was 2. That information will be missing because that gets written to the document as you're storing documents because the replication bundle is enabled. So if you don't have the bundle enabled and you're storing documents, that metadata just simply is not getting persisted. So you'll have your million documents in your database, none of them have that net metadata on them, and then that will cause problems as you start making subsequent updates to that doc. You'll get all sorts of conflicts on your destination node because it can't really resolve. It's going to have an unclear picture of who made this, how was this document previously updated. It's just missing part of the history there, and that's what causes the issue. Yeah, another question in the back? Okay, so the question is, okay, you're in that situation, what are your options? The options, I think they pretty much boil down to using Smuggler, right? Like spinning up a new server or new tenant with a replication bundle enabled, then using Smuggler to take all your data from your current tenant and import it to your new one. And that process of importing, since you have the bundle enabled, it will set up all the right metadata and you'll be good to go. The other thing that you can do is you can write if you have a small database or you want to invest time to write a process that can do this for you, if you simply touch a document after the bundle is enabled and basically do a no-op save on it, or you can even use the patch API to do this, just the act of doing that will be enough for Raven to go and put that metadata onto the document. So that is an option as well. You could write a patch script or something to just go patch all your docs, which again is just doing a no-op, but it ends up storing the right metadata. But those are pretty much your only options.
Real quick, I don't know. For authentication involved in this replication process,
Yeah.
so
Yes.
not just anybody can push data out.
Yeah, that's a good question. I didn't actually have a slide on that, but I'll answer. The question is there authentication involved with the replication process? And the answer is yes. If I go back to this slide here, one more, you can see that there's options here for username and password. So if you're using basic authentication, or sorry, that would be for Windows authentication, you can fill in those values there, and then that would be if your destination node is set up to require Windows auth, that's how you populate it. If you're using API key or authentication, you put the API key value in here, and absolutely that's required. You can't have, it's not just open to the world. Replication doesn't have any special privileges. It's just the source talking to the destination, hitting an endpoint saying, tell me the last document e-tag that I sent you. So it's all protected in the same way. Any other? Oh, go ahead. Pardon me? Yeah, so if you're using API key, the assumption would be that you have to be running on SSL because that'll be passed in the header. So yeah. Again, kind of like the same as the client, as the studio might be using to authenticate, to pull down the data. It's all the same security infrastructure. So we've talked about how that process works. So obviously the reason you're thinking about replication is likely because of high availability, though it could also be for reporting reasons. But you want to think, like, what's going to happen when one of these nodes fails? So great, I'm replicating data from point A to point B, and B just dies, goes completely offline. Well, the way that that's handled, the way that the API Raven gives you is client side. And in the client, you can set up this document store conventions, failover behavior, and you can pass in there's 4 different enum values. This is the default here, which is to allow reads from secondaries. So that means you're going through the client, the primary has failed, the client is now allowed to go contact one of those other destinations or secondaries, if you will, and do reads against that server. One thing I want to point out, I'm going to jump into some of the different options on the next slide, but one of the things I want to point out, because I learned this somewhat recently, and it was a kind of key thing for me, is that this is just a flags enum. So you can combine you can put different things in there to get the behavior you want. So for example, if you want to allow both reads and writes to your secondary, which would be kind of like the master-master configuration, but you also want to use round-robin reads across all your servers, you just simply pipe both those options in there and you can do that. So. The other thing to point out is that the Raven client is going to cache a list of all possible secondary nodes in persistent storage in the client. So that means even if your primary goes down and you've got 4 different secondaries, let's just say there's 1 different secondary you can talk to, and then the client crashes and has to be restarted, it actually has the persistent storage there in place. So the client can wake up, even though the primary is still down, the client still knows or has knowledge of what secondaries are available to fail over to. Excuse me. So the main options, there's one enum option, which is fail immediately, which basically just means don't let any failover happen. That's kind of speaks for itself. This one here, allow reads from secondaries, that's the default value. Basically, go ahead and read from a secondary, but never write to a secondary. And if you try to write if you have failed over to a secondary and you're trying to do a write operation, you'll get an exception thrown in the client. You can also set it up to say allow both reads and writes to your secondary node. And you'd only want to use this one. You'd only want to allow writes to your secondary if your secondary is set up with some way of pushing those documents back to your source. So again, thinking back to that master-master setup, if you're pushing, if you think about master-slave, you're pushing docs from A to B. A goes down, the client, let's say you let the client write a whole bunch of data to B. Let's just say your server A is down for a day or a week or something crazy. Well, now you've just written tens of thousands of documents over to B. Okay, now you fix the problem and A is back online and your client detects that and says, okay, I'm going to go back to A and start talking to A again. Well, those 10,000 documents that you wrote over to B while A was offline, I mean, they're just lost. They're not lost. They're still sitting on B, but from the client's perspective, they don't exist because he is now reverted back to preferring to talk to the primary, which was A, and all of those writes are effectively gone. So that is why the default behavior is to allow reads from secondaries, because if there's a secondary, it's a pretty safe assumption you could read from it. But you would never want to do writes to your secondaries unless you had that secondary set up to replicate back to your primary. So if you want to read from all servers, that allows you to say, do things like load balance your reads. So let's see, you have 4 or 5 different servers. Maybe you don't want to use sharding. This might be another option for you. You can say, I've got a lot of expensive query traffic coming in, and I want to be able to just, in a round-robin fashion, go hit all these different servers and run the queries against each of those, so I'm not really taxing one server on every request. Big caveat here is that this doesn't let you do optimistic concurrency. And this comes back to this lengthy discussion we had on document e-tags and how they're not consistent or synchronized or the same or anything across your different replication nodes. So you might be thinking, oh, this sounded like it was going to be awesome. I could use it to help me scale in a sort of simple way, maybe without sharding. Well, thankfully, there is an option. If you want to read from all servers and you want to have optimistic concurrency, there's an API here. When you're opening a session, you can pass in this open session options and set this flag to force read from the master, set that to true. And you might be thinking, well, doesn't that defeat the entire purpose of why would I bother reading from all servers if I'm just going to go back and force the reads to go to the master? Well, the idea is you would only use this strategy when you know you're going to write a document. Because there's obviously lots of situations, any get APIs you might have or query APIs, you know you're never going to do a write there, so let it hit whatever server you want. If you know, on the other hand, if you're in a controller action to save a user profile, well, on the other hand, you know you're going to write something, so go ahead and do this to force the read from the master. Now that you've got consistency on your e-tags, you can turn on optimistic concurrency, and you'll get the correct behavior that you're looking for. So what happens when a node just keeps failing? It's, we all understand there's kind of the client might get some transient error talking to the master, talking to the primary, but what happens when that thing just keeps failing? Well, what Raven does is server side, it's going to keep track of how many failures, the source will keep track of how many failures it encountered while it was trying to talk to each of its different destinations. And then what it does is it uses a backoff strategy. So I kind of tried to summarize what that strategy looks like. It's the type of thing that makes more sense if you kind of see it interactively, but I didn't want to take the time for that. But the idea is that if your destination node, if your primary has failed between 1 and 10 times, then the client is still going to go back on every request to retry again on the primary. So if I failed once in the primary, okay, great, I'll go hit the secondary. But then on the very next request, I'm just going to go back to the primary again because he's only failed once. So I'm going to assume it was just a network, some sort of chaos monkey in the system, something's gone wrong. So I'll go back to the primary, try again. Oh, he's still down, go to the secondary. Repeat that process until you've seen 10 failures on the primary. Then you're going to say, okay, the client's going to start trying to be a little bit smarter and say, okay, well, I'm not going to go back there every request. I'm going to back off a bit and only go back. I'm going to try again on the primary every 10 requests. And then once you hit 100 to 1,000, it'll be every 100 requests. And then after 1,000 failures on the primary, the client's just going to go back there. It'll always go back there every 1,000 requests. So you might think, well, why do I care, right? Like, this is an implementation detail, great, it's just going to work for me. Well, the reality is that if you didn't know that this is how the client was set up to work, you might see your primary failing, and you might see, in fact, we've had customers on RavenHQ have this problem. where for some reason they can't connect to their primary, and then they start complaining like, well, my application, it's still slow, like it's taking all this time, and the reason is because of this backup strategy. You still have to fail enough times against the primary before it will just basically give up and start directly going to the secondary. Go ahead.
Just one note, in Trio, one of the things that we are doing is changing this type of strategy. So on the second failure, it's going to always track always go to the secondary, and it's going to do heartbeats against the primary on a background thread to make sure that we know when it's happening.
Okay, that's awesome, because this is the type of thing that it works, but it's not ideal, exactly, because you kind of it means you don't get that you don't get the seamless transition off to your secondary. You're going to see a blip in your logs where what the heck is going on? These requests are really slow. So to summarize Oren for the mic, Oren was saying that in 3.0 it's going to be smarter, where it'll go directly to the secondary after 1 or 2 failures, and it will then do a background process to heartbeat back to the primary so it can know when that primary is back online. The idea here is you don't want to just go indefinitely against your secondary. You don't want to just be talking to your secondary for weeks on end when your primary was only down for 1 minute. So there's got to be some balance there between knowing when to go in either direction. Pardon me? Can you customize the backup strategy? Or you can comment to that maybe.
There's something called, there's a class called Replication Informer. It has virtual methods that you can override, and you can set the database which replication informer you want.
So the question was, can you customize this backup strategy? And the answer was yes, you can implement your own replication informer to do some of this for you. And I think, would that require you to implement some other things you didn't want to implement, or is it just the one override point? Override that method. Okay. So yeah, go ahead.
The strategy to peak off the secondary.
Yeah.
That was also customized.
That's this.
How you peak off which one you can read.
Yeah.
Also for informal servers.
Yes.
If you want to do more than just one token.
Yeah, so Lauren's saying if you want to do with the read from all servers option, maybe you don't want to maybe you want to have like a sticky session like ASP.NET or something, and have some metric that you can use to decide how requests should be directed to each of your nodes when you're doing round robin, or sorry, when you're reading from all servers. You can customize that as well through the replication informer. Okay, so the other thing with replication is you could probably heard of replication conflicts and conflict documents. And of course, that's something that normally only happens when you're running in master-master configuration. You have the capability to write the same document against 2 different servers. Maybe you wrote a different version of that document against two different servers, and now you have to deal with each server's trying to push a different version of that document to the opposite guy, and that's going to result in a conflict, and somebody has to decide what to do. So you can resolve those conflicts through the RavenDB Management Studio, or through a client-side resolver or a server-side resolver. On RavenHQ, we've gone with a strategy we offer to our customers who want to run master-master a server-side last one wins conflict resolution strategy, which was brought up on a previous session. And that we found that to be a very successful, like a lot of people find that just works for their needs. And I believe in 3.0, or you can confirm that, it's going to be built into the product to just give you an option in the studio. Yep, conflict resolution strategy is last one wins. And that'll be a huge benefit for the product, because, I suppose it could be dangerous, because if you don't think about the business implications there, you could have problems. But I think that's going to be a good thing to see that coming in 3.0. And really the point here, again, is like everything, like a lot of what we're talking about here, is it depends on what the business wants. You got to make an educated decision here. You don't want to just jump into this without understanding how the business views and interprets that data. So to kind of summarize some of the stuff we've talked about master-master, master-slave, with both options, you have data redundancy. You've got your data stored on 2 different servers. with both options, you can fail over on your reads. For failover on your writes, you need to be in something like the master-master configuration. You can load balance your reads in either type of setup, and with document conflicts, you're only really going to see those in the kind of master-master configuration. So last couple of things here is this idea of transitive replication. You might have seen that when we were setting up the replication destinations. There was a drop-down option there. You could say, do I want to do changed or change and replicated? And maybe you don't understand what that means. What this is really saying is, I'm the source. What should I do? When I'm talking to this destination, what should I, the source, do with documents that somebody else replicated to me? So I've got server A and server B. Though server B is set up to push documents to C as well. Let's say the Raven client is talking to A. And so transitive replication says for server B, when A pushes docs to B needs to decide what should he do. Should he push those docs through to C? That would be the kind of changed and replicated option. Or maybe B is only going to push documents to C that were directly modified on B. So there's different scenarios where this might be really useful to you. It could be that C is maybe it's a reporting database, or you've got two different data centers, and you're trying to just kind of synchronize these two different clusters or something. It's more of an advanced setting, but that's kind of the summary of what it means. The other one is skipping failover. This is a subtle one that on the surface you think, it's kind of why would I need this? So with this one, again, you've got server A, server B, and B is set up to also replicate to C. So you've got your client sitting there replicating, talking to server B, and then B goes down. And now the client needs to decide, okay, should I go to A or should I go to C? Well, you might think, well, why does it matter? They should both be in sync, right? Like, that's the whole idea of replication. Well, let me ask some questions, right? Like, what if maybe C is just there for reporting. Maybe C has some reporting specific indexes set up on it, and it doesn't even have your application indexes on it. So, well, if you let the client fail over to C, you're going to be in big trouble. He's just going to get exceptions, and he's not going to have any sort of meaningful data coming back. On the other hand, what if you got a large data set, you just recently brought C online, and you're still waiting for the initial replication to complete. Maybe you need a couple of hours for B to finish replicating data to C. Do you really want your client to fail over to C in that time frame? To users of your website, yeah, it's a silent failover and everything just keeps working, but wait, half of my data for the last 6 months just magically looks like it's not there. So those are the types of things you can leverage that setting. It's something you configure in the destinations doc or in the UI, and I would recommend you really think about how you might use that if you're bringing new nodes online.
Is that relatively new?
Is this a relatively new feature?
Okay.
Yeah, well, it was I know it's been in 2.5, but I don't know if it was in 2.0. It was in 2.0 as well. But again, it's subtle, right? Like, I'll be honest with you, I didn't learn about this until more recently, and I was like, oh, that would have been really useful for certain situations had I understood that.
We had a scenario where we used replication to
Right.
another, and we had it set up that way, and we had kind of this blind replication destination when we tried
Yeah.
structure.
Yeah.
A couple of failovers slipped through.
Exactly.
It wasn't real bad. But
Yeah, no, but
unexpected.
then you think about it, and well, what if it was also failing over on writes or something, and you're just missing context. So it's a really powerful feature, and just remember that that's there the next time you're thinking about setting up a node or bringing another node online or something. Okay, so to kind of summarize and bring it all together, with scalability and high availability, you really need to identify what problem you're trying to solve. You do not want to enter into this discussion without knowing what you're trying to do. You're gonna create so many problems for yourself, and you're gonna be changing your sharding configuration in production for no good reason because somebody else thought that was a good idea. So you got to own this decision if you're the decision maker, or be able to recommend choices to the people that are. And you want to look for simple changes, right? Like, if you can just pay more money and get what you want, pay the same amount of money and just scale up instead of adding another server for an equivalent cost, you really got to think about that. What's going to be simpler for you now, and what's going to be simpler for you at 2 a.m. when something goes wrong, right? Try and find ways of doing nothing, right? Maybe you have bad performance problems because your query sucks or your index sucks or something is written poorly. where you've got other resource contention issues on that server. So obviously the best option in any case is doing nothing. So look for those opportunities and try and do them. And don't be afraid to scale up. Scaling up sometimes gets a bad rap, like that's bad, you should scale out because that's the cool thing to do. But that's not always the case. You got to make the right decision. And if you do need to scale out, you're going to want to look at using sharding or replication if you're using RavenDB. So that's it. Any other questions? I'll go here first. Okay.
With the high-level cases, we had some issues with.
That's a feature that was developed for you.
Oh yeah, that's special to us. Okay.
I was going to say, I don't know about that feature.
Yeah.
So.
Yeah. So just basically we have to
Okay.
replicate to so many servers.
Right.
It's like everybody goes to each other, but we have one right master.
Right. Okay. Maybe we can talk about that offline, or are we just kind of sharing that for the feature? Okay.
Because it's something else you wouldn't think about until you run into
Yeah,
that situation.
that's right.
You need it.
Yeah.
A couple of things that, can you switch back to the failover? A couple of things that I wanted to, okay, great. There's a lot of very subtle things about failover, and I'm sorry for just barging in your
No, it's fine.
talk, but so skipping failover is one issue, and you actually had somewhere around here the UI.
Yeah.
Okay. Okay, great. So I'm sorry for how it looks. Not specifically for the silly Silverlight or replication. It's just that there are a lot of options here that we need to discuss. So we have the disable, which obviously disable applications just don't use that. We have skip failover, which is as important for, as Dan mentioned, for being able to set up a new server and then run with it. Also important is the notion of client visible URL. The client visible URL is very important if you have network topologies in which you replicate between nodes using internal IPs, but the client can only access them using external hostname or something like that. In addition to that, and there were questions there asked about authentication and security. Think about it. Me and Dan are two replicating servers. I'm replicating to Dan, and you want to talk to me. I'm down. So you're going to fail over to Dan. How are you going to authenticate against Dan? And the answer is that by default, we're going to use the same credentials, which is whatever API key or Windows authentication that we have for the primary server. If that fails, we will use whatever is configured here to talk to the secondary server. So you have to understand that when you put stuff here, in general, anything that you put here is available for every user. There was another option to store that in the config file if you want to hide it from users, but that's the basic idea. That when you're doing replication like that, you have to think about failover yes or no, about the client visible URL, about authentication.
We'll take a couple more questions, and then we'll probably have to cut off because we're a little bit over our time. Let's go. Was there one over here? Question over here or here?
That's just a quick question. I'm having trouble visualizing what happens when a server that's been a party server comes down.
Yeah.
And it's just it's not being on the secondary.
Yeah.
The party comes back up. Does it do something for PHP timeline where the secondary replicates back to the primary all of the changes like that?
Well, I can answer part of that. Maybe Oren can touch on part of it as well. The client's going to go back in the current implementation. If you don't customize the backup strategy, the client's going to be going back to the primary every 1,000 requests to determine that'll be how it determines if it's alive. But your question was more, just to summarize for the mic, his question was more about, okay, I wrote 10,000 docs on the secondary, bam, my primary comes back online. What happens I think your question is, what happens if the client starts going back to that primary before those 10,000 docs have replicated across? So I don't know, Oren, if you could comment on
it's a bit more complex in that there is the backup strategy, but we are actually very concerned about failing back to the primary server as soon as possible. So what happened, that you have a server wakes up, and he says, good to be up. And then he goes and talks to every server that it knows, all of its peers, and says, hi, Dan, I'm up. And whenever a client file over to Dan, it also tells, look, I can contact Oren, so I'm coming to you. You're my second choice. And because Dan knows that I'm up, he's going to tell you, look, here is your answer. By the way, you can talk to Oren, he's up now. So the common scenario of a primary server going down, even if it was down for a long time, is you're up, you're okay, and you start working with that. And yes, client will almost immediately realize that the primary is up and connect to it. The reason that we don't want to try to do okay, let's reject requests from client until we have sucked all of the data from Dan, is that that's a very, very complex operational issue. What happens if sucking the data from Dan is going to take 3 hours? What happens if we fail midway? So think about it. We have the primary app. We are trying to get data from Dan, and he's down. And in the meantime, you're trying to contact me and say, oh, no, I'm not available. Go away. But suddenly Dan goes down, and, OK, what do you do now? I know that they don't have the latest information. Do I accept requests? Do I reject requests? I have no idea how to handle that scenario. So the way it works, we are making the following setup available. When you go up, the server is available, client can connect and handle that. We will stream requests from the secondary servers to the primary one. In the meantime, you might see all the information. In practice, what we found people do, we go to the ops team and says, okay, we have a server down, it was down for 3 hours. Well, we have, 3 gigabytes of data that needs to move. It's going to take some time. So I want you to only open the connection between me and Dan. So client can still not see me, but this is now an operational procedure with a human that is actually looking at that and can make decisions. Because it opened the connection, and now you can see the document streaming. Then you can go into the studio and see, okay, replication status is okay. Now we can open this up for clients. So that's the story for the long down server.
I think we'll leave it at that for questions, and feel free to hit me up out in the back if you have any other questions you want to ask. So, thank you.